morning, everyone. I hope you enjoyed your nice snowy weekend because it's April and we need some snow because it's Minnesota and that's what happens. But let's move on to a happier subject such as Unit 8. We are done with Unit 7 and we are moving on to Unit 8, which is all about geologic time. So we're going to be talking about rock layers and how to identify the relative age of rock layers. We're going to talk a little bit about fossils, a little bit about dinosaurs. It's going to be a fun stuff. And then if you're someone that needs something to do with their hands while they watch a video, or if you're just interested, in the Week 3 folder, I have the Unit 8 notes, so you can use that and you can take notes as you go if you'd like. That's an option for you. There are two ways to specify age. There is the specific age of something, how many years it has. You can do it either if just by counting how old you are. So like if you are 14 right now, your specific age is 14. Or if this is something way older, like in the scope of the whole entire planet, you could do it by radiometric dating. So an example, the Earth is 4.6 approximately billion years old, or you are 14 years old. And radiometric dating, when you hear about carbon dating or uranium dating or zircon dating, there's also relative age. So not an age and number, but a comparison between two things. So the Earth is older than the moon, you are older than your younger sister. So it's comparing yourself, so it's a relative age. There are 3 laws or principles that are used to determine the relative age of rocks. And that's what we're going to be focusing on here, figuring out how old certain rock layers are. The first one is the law of superposition. Oldest to youngest. So looking at this, you can see rock layers throughout it. The ones at the bottom are the oldest, ones at the tops are the youngest. And then same with anything that's in those rock layers. So like this fish would be older than this monkey type thing. So the farther we dig, the farther back in time we see. Then we have the law of original horizontality, which is a mouthful, but it just means that things are deposited flat horizontally first. If they are not flat or horizontal, something must have happened since they were laid down. So, deposited in flat and horizontal layers, if rocks are no longer horizontal, they must have been tilted, folded, or uplifted after they were deposited. So we have these flat layers, that's how things are originally. They are not original like this. This happens because of some sort of plate tectonic shifting or an earthquake or some non-natural force maybe that happened, but this happened after they were laid down horizontally. Same with this one. They are not deposited like this. They are tilted upwards, and again, tilting and uplifting. If they show rock layers that are vertical, that means they've been tilted and uplifted. And then last one, the law of cross-cutting. So faults, so like faults in a tectonic plate where an earthquake might happen, a fault line, or igneous intrusions. So basically just kind of like columns of igneous rock that come up, because we again know that igneous comes from magma underneath the earth. So magma might shoot up through the crust for whatever reason. If there's faults or igneous intrusions, they must be younger than the rock they're going through. So if we have these layers, because of superposition, we know this is oldest, this is youngest, and because this, even though it looks like it's a tilted layer, clearly does not match anything around it. We know that this is an intrusion. This is something that has been cross-cut through all the layers. This is younger or newer than everything else it cuts through. So you can't cut through something that hasn't happened yet. So you can see here, this is a fault that goes through the layers. So this is a cross-cutting, and so it's newer than all this stuff that it's cutting through. So let's take a look at some examples. This is going to become a familiar picture to you with layers and things labeled. We have layers C, B, A, an igneous intrusion D, and a fault line E. Let's try to see if we can figure out the oldest to youngest of these layers. Because of the law of superposition, we know whatever is at the bottom is the oldest. So C would be the oldest here, and going to B, the next oldest, and then going to A. And then we have the two weird things. We have this crosscut, this igneous intrusion, and we have this fault line. Now, we know that D, this igneous intrusion, happened first or before E because E cuts through it. So we have our layers C, B, A, then D, and we know D comes next because it cuts through all of these layers. It even goes up to the surface. And then E is the last thing because it cuts through everything. And you can see there's a shift there. So E is the last because it cuts through everything, including D. And then another thing I'm going to ask you to do is tell me why that you think this is the oldest or the youngest. And you're basically just going to tell me which law does this kind of relate to. So C is on the bottom, so that'd be superposition. Same with B and A, just going oldest to youngest. That is citing the law of superposition. Then D, because it is an igneous fault no matter what, that is going to be cross-cutting. And E, it is a fault line, so it's going to be, again, cross-cutting. So that is one example right there. And then we have our second example. This one looks a little bit wonkier because it has a couple of cross-cutting igneous intrusions and a tilting of horizontal layers. So original horizontality is coming into play in this one. We know definitely that D and A are on the bottom. They've been tilted, but D is the bottommost, and then we have A. So we know that it's definitely D and then A. And then we have over here a little bit of B. Then we have B on top here, this kind of brick-looking layer. But not all of B is tilted, meaning that basically tilting happened first before majority of B. So the tilting of D and A, again, we can tell that this happened before B because B is not tilted, that the tilting happened next. So the tilting of the horizontal layers. And then we want to look at B, but we can actually see that there's something else that happened before B. We have this cross-cutting right here, this igneous intrusion, E, and we can tell that this is older or happened earlier than B because it doesn't go through B. It can't go through what's not there yet. So then we have our igneous intrusion E, then we have B, and lastly, we have C. We know that C is the absolute newest because it goes through everything, and so that is our newest addition. And then the geologic law that goes with them all, superposition and superposition. F, anything about tilting or shifting or folding, is original horizontality. E, that is a fault, or an igneous intrusion, so that is cross-cutting. B, just a normal horizontal layer, so it's also superposition. And last one, our igneous intrusion, is C for cross-cutting. So that is our second example. Our third example is this lovely guy right here. Take a moment and pause and see if you can do this yourself, and then unpause it when you want to hear the answer. We have all of our layers C, H, E, D, A, G, F, B, and then also tilting of J. And so we want to first figure out what's on the bottom. On the bottom, we have this C. So C and H and E, these are our first three that we know for sure. C, H, E, those are our first three layers. And then we notice that E is tilted, but G is not. So that means that the tilting had to have happened in between E and G. So next, we have J, our tilting of the horizontal layers. Then we're going to go up to G, which is our next just layer because of superposition. And then this is when we have to stop and think about A, because A goes through G, so that means that it's newer than G, and stops at F. So that means it had to have happened in between. And a nice thing just to think about is that if it's physically in between G and F, it's probably also age-wise in between G and F. So A goes up, stops in between G and F. Then we have to think about this D. D doesn't go all the way through F. It doesn't stop concretely like this one does. So you have a little bit of leeway with this one. I said that D happened and then B is on top. And again, your geologic laws, C, H, and E are all about superposition, just knowing oldest to youngest. Tilting is always original horizontality. G is another superposition. A is an igneous intrusion, so that is cross-cutting. F is just another layer, so it's superposition. D is cross-cutting because it's an igneous intrusion. Even though it's a really big one, it's still just an igneous intrusion. And then B, superposition. So these are some examples. I'm also going to post more examples in the extensions folder, so if you want more practice with that. And then we're going to talk briefly about fossils today, just in terms of rock layers. So which fossil is the oldest? So we have these fossils right here and these rock layers. Take a second and pause if you can, and figure out which fossil is the oldest. So we have this absolutely bottom rock layer, and because of superposition, we know this is the oldest. Only one fossil is here, so we know that the trilobite, or trilobite, whatever you want to say, is the oldest. Then which one is the youngest? This one's just a little bit harder because as we go through the rock layers, there are some like the gastropod. You can find it up here in the top layer, but you can also find it down here in the second to oldest layer. So that's probably not the youngest. So we're looking for one that's up top and not scattered throughout. So like this one, the crinoid. These are terrible names. You can see it's in this top layer, and it's only in this top layer. So that's promising. Oh wait, it's down here as well in the second oldest, so it had a bit of a dry spell, but it came back. So that's probably not the oldest. Because actually, as we go farther up, we see this over here. We see that we have a fern. And so this fern is in the topmost layer, and you don't see it in any other layer. So this fern is the youngest. So you're looking just for the topmost, and one that isn't fully scattered throughout. This is the notes you would have taken if you'd wanted to take notes. If you have any questions, please let me know, and have a great day.